Hi and Assalamualaikum to everyone. My name is Nurul binti Adam and my matrix number is GE220028. So today I'm from Group 1 and we would like to present our assignment, which is optimization and forecasting. Question 1 is about optimization using genetic algorithm and PSO, which is particle swarm optimization. And my part will be present about genetic algorithm. So first, I would like to present the manual calculation. So actually in GA, which is genetic algorithm, we have several steps that we need to do. And first step, initialization, as you can see at here, which is we define the A and B because in our equation is 9 multiplied by 10 power of negative 6 x squared plus 0.178x plus 49.454. And this is, we have two things, which is x squared and x, and we define as a and B, and from that we do the initialization. And next step is evaluation. So evaluation is function object, and we need to know the value of the absolute. When we put the at initialization, we define the A and B, right? So we need to put the value of A and B in initialization to evaluation. So we could get the function object from 1 until 6 because we do for the 6 chromosome. So next step is we do the selection. So in the selection, we do the fitness at first for the 6 chromosome, and the formula is 1/1 plus function object. We get the fitness, and then we total up. We total up all of the fitness, and after we total up all the fitness, we do the probability. So the probability is the fitness first will be divided with the total up. So from that we get the probability. So next we do the cumulative, and cumulative is we need to add up the probability one by one. So that's how we get cumulative. The final cumulative we get a 1. So next we do the R, which is number or random numbers, and we could get the pie chart from the new chromosome selected by rule, which is cumulative is decreased than random number and decreased than cumulative new, which is we need to add up another 1. So at here we could get a new chromosome. So from new chromosome we know that only 2 chromosomes that true, which is chromosome 1 and chromosome 2. And the next one we need to define it again. That's why we highlight as a blue one, which is chromosome 3 until chromosome 6. So next is step for crossover. The crossover is actually cut off chromosome with a new one. So as we can see from that random number 1 and 4 and 5, we highlight it because we do the new one, we exchange it. So next we do the chromosome 1 will be crossover to chromosome 4, and chromosome 4 will cross over chromosome 5, and chromosome 5 will cross over chromosome 1. So from that we could define the cumulative is 1, 1, 2. After we finish with the crossover, we do the mutation. So mutation is total gen equal to number of gen in chromosome and multiply with number of population. So we get the 12. So number of mutation we need to 0.1 times 12 and we get 1.2. So we do the approximately is 1. So from that we do the mutation 16, 23 and 02, 04, which is at chromosome 3 and chromosome 5. And we do again the function object to get a new function object. And we do the new chromosome with the next iteration, and there are new chromosome will undergo the same process as the previous generation of chromosome, such as evolution, selection, crossover, and mutation, and at the end produce new generation of chromosome for the next iteration. So it will be repeated. So at last, this is the result actually that we get when we try to demonstrate first before this. So the optimization is at the current iteration is 116, and we could get the A value is 32.605 and B value is negative 276.642. And when we sum up at here, we substitute, we could get the negative 49.473 equal to negative 49.45454, which is negative 49.454 is our value, the real value in the equation, but the negative 49.473 is new value. So from that we can get, with the round off, we can get the negative 49.5. So next we will do the demonstration. So I will do the demonstration on the MATLAB. So this is MATLAB file that I already mentioned to do the demonstration. So unfortunately, we just only use this. This actually we get from the equation from the given from the equation. So we just put it here and put the absolute. So we run first. So it will go out like this. But you need to pick the apps and pick the optimization toolbox to do the genetic algorithm. So we will wait. And from this we need to extend the solver as a genetic algorithm because we want to do the genetic algorithm. And the fitness is we need to put as a alias, and we just copy back the file name, which is my fitness, and put back. And as we can see from the equation, we have only 2 variables, so we put 2. And then this one really doesn't need to extend, but the selection function I will choose as the roulette. So that's all. And then we just put the start and the optimization we're running, and we could get 151 iteration, and we could get the final point for A is 125.493. And as we can see, okay, we put at the calculator 0.0009 times with A plus with 0.178 B for the variable, second variable, we will put the soft. As you can see it here, soft. So A is we put as our value 1 to 5, 1 to 5, 1 to 5.493, and the second one is negative 277.38. So when we sum up, we could get, I will show you guys this one. We could get negative 49.494. So that's how we get the answer. Okay. So next, I will give to the next presenter. Thank you.
Hi, my name is Muhammad Amir Shambirazan, and my matrix number is HE210043. So the question assigned to me is the particle swarm optimization, and I will present to you. So we have two kind of calculation here, which is the first one is the maximization problem and also the minimization problem to find the roots. Okay, so the first one is the maximization problem, which is the purpose is to find the maximum value of a given object function, which each particle in the sum represents a potential solution that's actually, and then has a position and velocity in its search space, and then position of the particle represents the solution and velocity represents the step taken by the particle to move forwards to a better solution, which is the maximum value. Okay, so there have been a few steps, which is the first one is we initializing the base of parameters, which is the iterations and also the current position of the particle. So the data tabulates all of the data. And then for step 2, we are going to find the object function, which is the fitness function given by the formula of this one. Okay, so this formula is actually derived from the table, from the data sets that we have collect. And then so after that we compute the value of x so that we can get the value of fx. Okay, so let I move my camera a little bit. Okay, so for step 3 is evaluating the LBP and LBF. So this one is actually the maximum value of the data sets. Okay, and then step 4 is updating the value equation for next iteration, which is iteration 2, and we are using this formula. So after we compute this formula to the V, we get this velocity of the particle updated from the first iteration. Step 5 is the updating the position or x value for iteration, and then we get this value for the x. Before that, we are using this equation xt plus 1 equal to xt plus vt plus 1, and then the last step is evaluating the maximum LBF and LBP. Sorry. Okay, so for that is we acquired the same LBP and LBF, which is the 1022 for the LBP, and also the LBF is 241.588. Okay, for the demonstration for this maximization problem is we are using the MATLAB code. We are using the manual MATLAB code. So here we initializing the parameters, and then we initialize the local base position, and it has been updated for next and next iteration. And then we get this value. So the value of x is the position value for the first iteration, and this one is for the second iteration. Okay, so for minimization problem is how we want to find the roots for our function. So we are using the MATLAB tools here. So we plot the code and also the formula so that we can get this value here. So there have been two types of code that we are using in this project, which is the first one, we don't set the upper and lower boundary, and then the second code we set the upper and lower boundary. So there has been a difference in value actually. So you can see here by not using the upper and lower boundary, the roots here is these two, and also when we use upper and lower boundary, we get these two roots, 0 and negative 15. So what's the difference? What's the difference here is that if we refer to the documentation, the solution for not having an upper and lower boundary is actually is far from the true minimum. So that's why we set the upper and also lower boundary to get the best possible values. Okay, so that's why we get this value. Okay, I think that's all from me. I will pass to the next presenter. Thank you.
Okay, this time I'm going to explain about how to forecasting and data and solve a problem by using fuzzy logic. I will explain how to do economic calculations in Excel in this presentation. So first of all, of course, we have to have a data. As the lecturer explained, so we are free to take wherever the data from. So this time I'm taking the data from electricity of Indonesia, my country. And first is we have input data. So in this step, we're required to input some basic data such as year, right, year, then type, the type here, T, and actual data. Here is per year of Indonesia electricity installing capacity. Type is refers to a various of Indonesia electricity enterprise in Indonesia. It is representing also then the enterprise in actual is total electricity enterprise based on their types in Indonesia. Furthermore, we do short step to format the data smallest to largest using the following equations. This is the equation that I use to sort the data from smallest to largest. This when you want to sort the data into Microsoft Excel, just write down the equals for the, like this. This is the short line, so a short column of data, actual data. So just block all the lines line first, then you type equals, and then you write SORT, sort, and actual data first until actual data 9. So just block also from this first data to the last data. Then we will get this all data from the short data. And then the type is the models of electricity enterprise in Indonesia. So I assume that each enterprise is represent number. So this is electricity enterprise first, electricity enterprise one, and I assume to be one, to be number one. And next is number two, three, and then the ninth enterprise. Next is seeking AD absolute data, and then we're looking for ATM, UAD, sigma, bow, and alpha bow. So this is the data I've gotten from the process. So to obtain these two data, we could utilize for D. So we use this D as our central data in this step. The equation is to get the, let's say, the absolute data, absolute data. So we can use equals absolute, and we got the sequence of data and minus the first place of data, and we'll have this our column data. For looking for ADI, the equation is in the equation. This is the equations. Error d minus ed power 2. Thus, we should have AD data first by using these equations. So to know to operate these equations, so we need to operate AD step first by using these equations. Operate with value d1 until value d2. So operates to all this data, we got the AD data, then we go to this step. After that, we are going to compute with ADM equation above. Next is computing sigma with equations. This is the sigma, this is the AD data, absolute data, this is the absolute data, this is the sigma data, and low bow and upper bow data. Low bow is sigma, so we can use equals SQRT squared, relate to value ADM is one value from the first data until the end of data. So after we using these equations, so we can already have the 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 data of sigma, like this of sigma. And the data we use the equations of rate value d 19 value d until value d 88. This value represent the value from my Excel data. Then after we determining, sorry, computing the new AD, so next to low bow and upper bow. For equation, to look for low bow is using equals the first value sort the new ideal value. So for low bound, so we have to go to our value sort number one minus new AD value, this one AD value. And then for equation for UB, UB or upper B, tray up above is equals last value sort. So the last data of sort minus new AD value. This one is the value of new AD. And the dividing fuzzy set. To dividing fuzzy set, this part we're going to figure out this fuzzy influence system. But before that, we have to have fuzzy set as shown in the left side figure. This one basically defining for length of data as A1 to A72. Next is dividing parameters trapezoidal fuzzy set A, B, C, and D into the data. For fuzzy set A1, the parameter A use value global, and parameter B is using equations. Parameter A equals parameter A plus constant new AD value. Now parameter C is utilizing equations. Parameter B plus constant new AD value. Parameter B utilize parameter B plus, parameter D plus parameter C, parameter C plus constant new AD value. For fuzzy set itu, parameter A and B utilize formula parameter C and D plus constant new AD value. Nah, for parameter C and D fuzzy set itu just drag down parameter C and D fuzzy set A1. Therefore, to get all fuzzy set data, select data fuzzy set A1, A to D, then drag down till the end of total data you have. And this build fuzzy logic designed for MATLAB. So after we got all, we have all this basic data to operate in MATLAB. So we go to MATLAB. So in MATLAB, we'll write down and value. This is the actual value. This is the actual value. To go to design it, we go to app, go to fuzzy logic. This one, fuzzy logic. After we click the tools, so the method will show us this catalog, right? So this step, this catalog will get us how to solve the problem by using fuzzy logic. This one also, this is the Sugeno technique. For the first time, the method will show us the Mandani. The next is we need to add more the catalog and Sugeno catalog. Then we go to double click to have this next catalog. Is just double click the input. Then the method will show us this catalog. Right, now in this catalog, we will add the data from A1 to A72 one by one. Right? By edit the parameters, value parameters, value A, B, C, D for A1. We put it here. This is A1. So this is the parameters, all A1 parameters. And then we edit it one by one until we have the data until A72. And then after we already designed and input, then next do editing to output sessions is fine. Also, we add the data from one by one to member function one until member function 72. These parameters, this is the name of the data. We add one by one, and more I mentioned, one by one of the data. And this is the rule editor, the fuzzy logic process. We edit one by one also here. A1 if A1 input and output, right? A1 if, for example, like this, if input is A72, then output is member function 72, and we add it like in previous, maybe one by one. After we're done this process, we will have the result of the fuzzy process. This is the fuzzy designer with fuzzy ruler keyword for this. So this is the keyword of the fuzzy logic. Last is after we have already done our process in MATLAB, and this we're looking for is MA, MSE, and MAPE. The last is analysis get midpoint value with formula. Alright, this is the formula for us. Parameter A value, parameter B value. Where these operations determine membership function in MATLAB. And then this value comes from forecasting value of actual data. In order to obtain the value, should be done fuzzy logic process first, as I mentioned earlier. Now run the code written in MATLAB. Thus, you just need to copy and paste the forecasting value to Microsoft Excel. This is the paste data from the MATLAB that I copy and paste here. Next is seeking E. In our analysis, utilize the formula. And we looking for the CE, squared error, using this formula. And next is RE, relative error, using this formula. And to get MA, MEE, MAE, In absolute error, we use this equation to this formula. For MSE, mean square error, use this formula. For it, hence, to look to have an EPE results using this formula or these equations. That is all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Morning, my name is Lazarina Mariana. Today I want to presentation about artificial neural network. Artificial neural network is one of the method to forecasting data time series in electrical engineering. So the step one we must do, we have data time series. The data time series is data on installed capacity of power plants generator in Indonesia from 2013 until 2020. We have 72 data in Microsoft Excel. Step 2, we open application MATLAB, and then we open application neural net time series in MATLAB. So we click this option, the first option. Okay, step 3, we must to select data, which input data is logged in and the target is logged out, like this. Okay, next. Step 4, we must do validation data. The validation data like this, we must to adjust 70%, 15%, 15%. Okay, next. Step 5, we must define the hidden number. The hidden number defined of our data. Like this, we must to calculate our data and we get 52 hidden number. Next. Okay, step 6, we must to run our data so we can get the result of our data. Okay, next we must do demonstration what I said before. Okay, this is our data in my data in Microsoft Excel. So the year, type, and the time, and then this is the actual. The actual is data capacity of generator. Okay, we have this. The yellow color is input data, and then the blue color is output data. So we have 10 columns. Okay, next, this is data in Microsoft Excel. We put in next. Okay, we put in our data Excel in MATLAB. So we label data input is logged in and we label data output is logged out. So we click this. We click application neural net time series. It is. Sorry. Neural net time series. This. And we can see we choose first option, this, and next step, next, we input data in, select data, log in, target at log out, and the time step in matrix row because our data is aviation matrix. Next, we must do validation our data and we adjust in this 15%, okay. Next, we number hidden number, okay, we put it